Okay, ladies and gentlemen, welcome back. We're going to look at limits of a special type of function now. Limits of absolute value functions. Now, I've done one of these already with you, and so you think you know what you're doing, but I have to tell you, there's a lot more going on than we remember, or that you've ever been told. This is something that's out of the math curriculum, to be honest with you, that we need to talk about now because it's going to show up in calculus. So let's consider y equals f of x, and let's let f of x be our function. Oh, not the root x. There we go, absolute value of x. Where, and let's give it a domain where x is an element of the real numbers, which means it can be anywhere at all. So you should remember from grade 11, depending who your grade 11 teacher was, they made a bigger deal or a lesser deal out of knowing this function. This is the function f of x equals absolute value bar x, and it goes in both directions. And if we think about this function in terms of what I've introduced you to, this multiple personality type function, we could think about this function in terms of f of x representing x if the x value that I'm putting in is positive, greater than or equal to 0, and it would be equal to negative x if x was a negative number. And what I'm trying to say here, and I think you'll see it very quickly, if I look at this line here, this is the y-intercept, so the b value is 0. So if we remember back to grade 9, y equals mx plus b. My b value is 0 here because it's crossing 0. So let's look at its slope. So if I go over 1, I go up to 1. If I go over 2, I go up to 2. That's going to be a slope of 1. So what happens is, this is actually y equals x, isn't it? This line here. This is y equals x. So if I put in any values of x that are greater than 0, I can just use this function y equals x, which is what I'm saying here. So if I'm on the right-hand side of 0, it's simply y equals x or x. However, if I'm on the left-hand side of 0, you guys have learned to do something. And it's kind of funny what you've learned to do. Somebody along the line told you that when it's negative 1, the absolute value bars take away the negative. I'm not sure who told you that or who started telling teachers that that's what's happened. That's not what's happening. The negative bars don't just go away. They don't magically disappear. What happens is we take the negative and we multiply it by a negative, and it becomes a positive. And so when I have a negative 2, it actually gets multiplied by a negative, and it goes up to positive 2. And so this line here is actually y equals negative x. And that's the line that would cross through 0, 0. And basically what the difference here, guys, is, what you really have to realize, is that for up until now, you guys have all been thinking that when you see something like this, that the absolute value bars magically get rid of the negative. They don't. What they do is they take the negative 3 and they multiply it by another negative and make it 3. That's what's actually happening. It's an active function. That's the absolute value bars. That's what's happening with an absolute value. When the argument of what's inside the absolute value bars is going to be positive, then that's fine. It's just the argument of what's inside the absolute value bars. But when the argument of what's inside the absolute value bars is negative, we multiply that argument by negative. So let's see how that's going to play out on some more interesting questions. So example 1. Evaluate, which is a better way to say compute, evaluate the limit as x approaches 0 of the absolute value bar of x over x. So that's a very interesting question. And notice that the value that we're getting close to, the limiting value of 0, has two sides of it. There's sides where x is going to be approaching 0 from the left, and there's sides where x is going to be approaching 0 from the right. And all of these sides are going to be positive. These are all values that are greater than 0. None of these values are going to be negative. they're going to be values that are less than 0. So we're going to have to pay attention because our domain is going to have some negative values for this argument inside the absolute value bars, and it's going to have some that are positive. So what we do is we say to ourselves, well, you know what? These things change a little bit. So if I'm trying to do this, the absolute value of x over x is actually a multiple personality function. And it's going to equal plus x over x if the values that I'm putting in of x are greater than or equal to 0. But it's going to be negative x over x if the values that I'm putting in are negative, because we need that negative to get rid of the negative that's being put into the function. Do we understand what I'm trying to say here? I'm getting some nods. So this is a good thing. So that means when I go to do this and I try to set up my function, what I'm going to have is the limit as x approaches 0 from the left of absolute value of x over x is going to be working on the limit as x approaches 0 from the left of negative x over x. And you're going to notice that that equals negative 1. And the limit as x approaches 0 from the right of absolute value over x is actually going to be the limit as x approaches 0 from the right as positive x over x, which is 1. And you're going to realize that negative 1 and 1 do not equal each other. So since the limit as x approaches 0 from the left of f of x does not equal the limit as x approaches 0 from the right of f of x, we say that the limit as x approaches 0, and instead of calling it f of x, I'll call it what it was, absolute value of x over x, does not exist. And if we had to draw a picture of what this looked like, ladies and gentlemen, on this side it would look like this, and on this side it would look like this. And that would be the graph. And notice it's undefined at 0 because I can't have 0 over 0. That's a problem that we're going to talk about later on. And that's what the graph of this function would look like, those two parts. I'm going to stop the video there and I'll come back with the last example in this section.